Hey everyone, welcome back. So today we're going to be solving another lead code question. So I'm going to be doing a lot and lots of problems on DP, right? So I would say this is a series that I'm starting on DP, and I'll try to solve as much of problems that I can, right? And I'll try to teach the problems that I solve to the people that are not able to solve the same problems. Right? So most of the people who upload solutions to LeetCode, they do it prior to the video and then they upload it. But I'm gonna be doing something a bit different. I'm going to be solving it on the video itself, right? So each of the videos is going to be longer time, but the reason that I'm doing this is because if I'm stuck somewhere and I figure it out, right? I come out of that loop where I'm stuck. Maybe some of you who watch the solution, the reason you came to watch the solution is because you're also stuck at the same point, right? You will figure out where you missed something and then how you're able to overcome that, right? So my that is the reason I'm trying to solve it on the call. Every video is going to be raw. I'm not going to edit any of these. I'm just going to upload what it is, right? Maybe I'll make some stupid mistakes, maybe I won't, maybe I'll get it on the first try, maybe I'll get it on the 100th try, but everything will be on the call, right? Yes, so let's get started. And yep. Okay, so the problem states that you're given you're climbing stairs and it takes n steps to reach the top, right? Each time you can either climb one or two steps, and how many distinct ways can you climb to the top? This is given as an easy problem, and I have attempted it, but I'm not, solved it. I'm going to be doing it on the call. Okay. But I don't think there's an easy problem. It's a medium level problem because there are two main concepts behind this. One is backtracking, and second one is DP. Right. Under DP you have memoization. If you know these concepts, then maybe it's simple, but I would not consider this as a simple problem, right? Because even if you know one of the concepts, let's say backtracking, and you figure out the approach, you're gonna get a TLE or memory limit exceeded error. Because there is a way to optimize the brute force way, which is backtracking, and that is why we use DP with memorization, right? So see, the thing is, one thing about these kind of problems, right? Whenever they ask you, what are the unique ways, or what are the different ways, right? Give me all the possible answers. In that case, since you have to explore all the possibilities, it can be done only in a brute force way, right? It can be done only in a brute force way. Now, you can never optimize it. You can never skip anything, because all the answers that you get are the answers, because all of them are possible answers, right? So the only way you can optimize it is by storing it and not making that call again. That is something we'll look at it in this problem, right? But what I'm trying to say is, if a question is given to you and they ask you to figure out the unique number of ways, or how many ways we can do this, right? You always need to think of in a direction of brute force, right? Okay. And if you see, whenever you are given such problems, your constraints will also be considerably low, right? On a lower range. Okay, perfect. Let's get started. Okay. So the question says that you can take one or two steps, right? Let me take an example. Okay, let's consider you're currently standing at the ground, right? And then you're currently standing at the ground, right? And then you can take one step, two step, three step, four, right? So first step, second step, third step, fourth step, right? How many possible ways can you go? Okay, let's look at it visually. You can either take 1, 2, 3, 4, that's one way, or you can take 2 and 4, that's another way, right? Or you can take 2, or you can take, wait, you can take uh, 2, 3 and 4. That's the third way, right? Or you can take 1, 3, 4. That's the fourth way, right? Or is there any other way? No, I think there are only 4 ways. Yeah, I feel the answer is 4. Okay, perfect. Now let's see how to solve it. Okay, let's do one thing. Let's figure out all the possible ways in which you can reach the top. Okay, so right, let's do one thing. Let us come to it from the top itself, right? Let's say you're at 4. Let's figure out how many ways are there to reach 4, right? And then we'll break that down. Then we'll go to a smaller problem. Let's figure out how many ways are there to reach that smaller problem until we reach a base condition, right? So what I'm saying is, I have ways of 4, right? Okay, how many ways are there to reach 4? Okay, I will consider another this thing, right? You're standing over here, right? You can either come 1, 2, 3 and 4, right? Yes, you're currently 1, 2, 3 and 4. Okay, so you're currently standing over here. Okay, how many ways are there? Okay. You can either take this step, or you can take this step, right? So you can take both the ways, that is either take one step or two step. Okay, so I can either take ways of 3 or ways of 2. Okay, when there's a sense of or, in that case what do? We add it, because the question is asking us the total number of distinct ways you can reach to the top. So ways of 3 and ways of 2, right? Now let's see how to reach 3. Okay, ways of 3 can be broken down into ways of 2 and ways of 1, right? So when you are at 1, you can reach, when you are at 1, you can reach 3 directly, right? Or you can go like this, right? So there are 2 ways. So actually, yeah, when you're at 3 also, you can either take this step or you can take this step, right? Perfect. Now what are the ways of reaching 2? You have 2 ways again. You can come from ways of 2. What are the possible ways that you can take from 2? Right? You can either come from 2, you can go to 1, right? Or you can go to 0, right? You can go to 0. 0 is what? It's nothing but the ground. Okay, perfect. Now ways of 1. Okay, how many ways are there to reach 1? Let's think about it. Ways of 1, it's either ways of 0 or ways of minus 1, right? Minus 1 is not valid, right? Minus 1 is not valid. So what are we going to do? Let's not even go through this part, right? There's something called, there's a concept called as there's a concept in backtracking called as, I forgot the name, but what it does is basically you see if you can go to that path. Either you go to that path and retract, or you just don't go to that path, right? From here we won't go to this path. Okay, so from ways of 0, okay, let's ways of 0. Okay, when we reach ways of 0, let me ask you a question. Okay, how many ways are there to reach 0? How many ways are there? Is it 0 or is it 1? Ways to reach 0 is ideally 1, right? Why? Because there's only one way. There cannot be 0 ways to reach 0. What is that one way? You're already standing at 0, right? You're already standing at 0. That is the only way, right? There cannot be 0 ways to reach 0, right? There's one way, which is you're standing at 0, right? So we have hit our base condition, and base of 0 is going to return 1. Again, why 1? Because you're standing at 0, that is one way to reach 0, right? There is no 0 ways to reach 0, right? So I will return 1. Now, how many ways are there to reach 0? Same thing, 1. So this will return 1. So how many ways, what are the best possible ways to reach 1? There's only one, right? Perfect. So this is going to return 1. 1 plus 1, this is going to return 2. Okay, let's validate. How many ways are there to reach 2? You can either from ground, you can either go like this, right? Or you can go like this. There are only 2 possible ways, and that's exactly what we have got, right? How many ways are there to reach 1? We have already calculated over here. This will again break it down into ways of 0 and ways of minus 1. Right? Now, ways of minus 1. Right? Now, this would return us 1. Right? Okay. Now, this, when we're going to add it, we're going to be returning 3. Right? We're going to add it, we're going to be returning 3. Okay? Let's check. How many ways are there to reach 3 from the ground? There is 1, 2, 3. Or there is 1, 3. 2 ways done. Or there is 1, 1, 2, 3, 1, 3. Or there is 2 and 3. 3 ways are done. Right? So perfect. We got in the right answer. How many ways are there to reach 2? We have already gotten it as 2. We will be returning 2. This will be returning 3. So how many ways are there to reach 4? There are actually 5 ways to reach 4. So the answer we have gotten is actually wrong. There are 5 ways to reach 4. Okay, 5 ways to reach 4. Perfect. Now, let's go this up, and it is gonna fail, but let's try to optimize it after that. Okay. So, okay, we'll write a separate function. Okay, let it be a public function only, and this will have a return type int only. Right here, what we'll be doing is right, we will call it recursion. Okay, and then we'll be taking int n, right, n itself. Okay, we will come to the base condition later. Now, going to the next one, right? If n minus 2 is greater than 0, okay, n minus 2 is greater than 0. Do I need to write it like that? Full and 4, I'm coming to 3, I'm coming to 2, ways to reach point, right? 3, 2, 1, 0. 3. You know, let's not handle it over here. Let's do one thing. Let's take int sum equals to recursion of n minus 2 plus recursion of same thing that we did, right? N minus 1, right? Now, our base condition would be if n equals to 0, I need to return 1, right? If n is less than 0, then I'm just going to return 0. Perfect. Done. Now what I'm going to do is I'm going to be calling return. Okay, I need to return the sum over here. I'm going to be returning sum. Okay, return recursion of. Okay, let me run it. Okay, I got a compiler. Okay, let's okay, perfect. Okay, now let me submit it. It's gonna fail. It's gonna throw MLE or TLE, right? TLE, right? Why TLE? Let me explain. Okay, see, when we were over here at 2, right, we were making a recursive call to 1, making a recursive call to 0, right? When we were at 2, we were making a recursive call to 1, right, and we're making a recursive call to 0, right? Now again when we come to, so this is the left subtree of the recursive tree and this is the right subtree of the recursive tree, right? In the left subtree we already calculated what is the value for 2, right? Over here this part ran and we calculated what is the value for 2. How many ways are there to reach 2? It is 2. We already calculated it in this particular path. Again, when you're coming to the right subtree, we are calculating it again, right? So how is the recursive call running? For ways of 2, it's calling ways of 1 and it's calling ways of 0. Again, ways of 0, right? Again, the same thing is running and then it's returning. So think about it. If your input is 44, how many recursive calls will be made? Unnecessary recursive calls, right? What will be the time complexity? So if you have so on the first call you'll be making 3 and 2, right? For 3 you'll be making 1 and 2. For 2 you'll be making 1 and 0. For 1 you'll be making 0 and minus 1. For 2 you'll be making 0 and 1. For 1 you'll be making minus 1 and 0. For 0 you'll return the value, right? So look at the recursive call. This is 2 power 0, right? This is 2 power 1, this is 2 power 2, this is 2 power 3. It'll keep on going until 2 power n. So your time complexity now is 2 power n, right? So it is running for 2 power 44 cases it's running, right? Since it's running for so many cases, you're getting a TLE. Now we'll have to figure out a way to optimize this, right? This is where your memoization comes in, right? What are we doing? We're just going to hold that value, right? So what am I going to do is, I'm going to store that value somewhere. I'll create an array, right? As simple as that. I'm going to call it dp new int of n plus 1. Why n plus 1? Because we need to find the value of the nth number, right? If we need to find the value of the fifth number. If I'm forming a dp of n 5, your dp will only range from 0 to 4, right? So to form the dp for the nth number, we need the value of nth number, right? So for 5 I need to create an array of size 6 so that it's covered from 0 to 5. Okay, now what I'm going to do is I'm going to fill this array with minus 1. Why am I filling it with minus 1? That's a good question, right? You might be thinking why is Siddharth filling it with minus 1, right? Let's think about it. At some point I will retrieve the value from the DP array, right? Can number of ways to reach a particular point be 0? No, it cannot be 0. Actually, we don't have to take it as minus 1. We can leave it as 0 itself, because there can be no number of ways, there can be no number of ways to reach a point that is equal to 0. By that what I mean is, number of ways to reach 0 itself is 1, right? That's what we saw over here. Right? Number of ways to reach 0 is 1, right? So there can be no possible way where the answer is 0, right? So let us keep it as 0. Perfect. Now what I'm going to do is I'm going to pass the DP array, and then here also I'm going to pass the DP array. All I'm going to do is I'm going to check if DP of n, right, is not equal to 0, then what I'm going to do is return dp of n. What am I doing here? I'm returning the value. So if dp of n is not equal to 0, which means that we have the number of ways to reach that nth value, right? If I've stored the nth value for 2 as 2, right? The next time I come here, this value will not be equal to 0 because dp of 2 will be set to 2, right? So I will just return 2 over here, okay? And what I'll do simply here is I will store it at this point and I'll return this, okay? Now it should run, okay? I'm gonna compile, okay, because I'm not calling it over here. Let me call it over here as well. Now it should run. Perfect. Let me submit it. Perfect. Right, now it went through. What is the time complexity now? You're only going through it once, right? When you're calculating the values, when you're adding it to the DP, you're going this particular way. Right? And you're storing all the values, right? So from 4 you have reached 3, you stored it, 2 you stored it, 1 you stored it, 0 you stored it. The next time you come to 2, you're just fetching the stored value, which is O of 1, right? So what is the total time complexity now? Since you're going through the entire array only once, your time complexity would be O of n, right? So if you see over here, that would be the time complexity. Perfect, right? Yes. So this is all it is for this problem, right? I hope you understood the solution. Yeah. I'll catch you on another DP video. Right? Thank you.